Hello students, welcome back to my YouTube channel for the next video. In this video, we'll see that heap sort algorithms. It is one of the important technique of sorting in data structure. So let's see this heap sort algorithm. Heap sort is one of the best sorting method being in place and with no quadratic worst case running time. Heap sort involves the building a heap data structure from a given array and then utilizing the heap to sort the array. Now, basically, if you talk about this heap sorting, it is based on the tree. Wherever and whenever we do it, it will be first of all we have to make the tree, and then we have to perform the sorting. How the heap works? Heap sort algorithm is divided into two basic parts. First of all, creating a heap of unsorted list, or you can say the array, and then sorted array is created by repeatedly removing the largest and smallest element from the heap and inserting it into the array. The heap is reconstructed after each removal. Now, if we are talking about this heap sorting, right, we can store in the array, but we are using this algorithm based on this tree also. So there are two major steps while we are performing the heap sort algorithm. There are two major steps. First one is the first major step is involves transforming a complete tree into the heap. As I said, whenever you can do this heap sorting, first we have to make the tree. We have to make the heapify tree, you can say. The second major step is to perform the actual sort by extracting the largest or the lowest element from the root and transforming the remaining tree into the heap. Now here, largest element as well as the lowest element, you can say. If you apply the Max-heap method, if you apply the min-heap method, then we can use the largest number, or you can say the lowest number. Now see this types of heaps, because when we apply this largest element, or if we apply this lowest element, then we have to use the Max-heap method as well as the min-heap method. So there are two methods to do the heap sorting. One is Max-heap method, another is min-heap method. Now when you're talking about this Max-heap method, Max-heap means that the root will always be greater. Root will always be greater than the child nodes. See, at the top, 19 is the root, 12 and 16 both are the child nodes. So 19 is greater than this 12 and 16. If you come to this next level, level number 1, 1 and 4 both are the child nodes, and 12 here is a root node. Same thing, 7 is a child node, so 16 is a greater. That means in case of Max-heap method, whenever we make the tree, that root should be greater than the child nodes always. Second is min-heap example, min-heap method. When we apply the min-heap method, now always we have to see the root always be smaller in size. Root always be smaller in size than the child nodes. See here that 1 is the root node, 4 and 16 both are the child nodes. So 4 and 16 both are greater than 1. And if you go to the next level, 4 and 16 both are the roots at level 1. And for 4, 7 and 12, these are the two child nodes. So 7 and 12, these are the nodes which are greater than 4, and 19 is greater than 16. That means all the root nodes are smaller than the child nodes. So we have to use either min-heap method, either we have to use Max-heap method. So when we apply the Max-heap method, the root always be greater in size than the child nodes. And when we apply the min-heap method, then the root always be smaller than the child nodes than the other methods. Now see the example here. So what we'll do, we'll see this Max-heap method. So what is Max-heap method here? It is a complete binary tree in which the value in each internal node is greater than or equal to the values in the children of that node. So if you apply the Max-heap method, the root node always be greater than the child nodes. Max-heap property. The key of the node is greater or equal than the keys of its children. Always we have to use this method. Max-heap operations, how it will be done, right? So we'll always be starting from this root node. The heap can be sorted, stored as an array. So first of all, if the number is given, you have to make the tree first, and accordingly you have to do the sorting. So root of the tree is here even, then you have to choose. So how we are making the tree? Because if numbers are given here, that 16, 14, 10, 8, 7, 9, 3, 2, 4 and 1. If numbers are given, then what we'll do? Always we'll start with the first number here. So here the 16 is the first number. Second number is a 14, right? So it will go to the left side. It will go in the left side. 14 will go in the left side. Now the third number is 10, and this 10 will be in the right side, because at the second level there are two maximum child nodes. There are two maximum child nodes. And also if we are using the Max-heap method, we have to see that the root node always be greater than the child nodes. So 14 and 10 both are smaller than the 16. So now it is correct. We'll go to the next level. At here 16, because the next number is 8 here. So that will be the left child of 14. And here that 8 is smaller than 14. Now the next element is here 7. Again if you add this 7, that will be the right child of 14. And again the 7 is smaller than this root node. So both the elements should be smaller, and you have to check. Now come to the next level. 10, the root of this 10, right? So the left child will be 9 here, and the right child will be 3 here. And both the elements are smaller than this 10. Next element here, 3, 2, right? So here the 2 will be taken here. So 8, the left child of 8 is here 2, and the right child will be 4 here. And the last element is there 1. So accordingly we have to make the tree. We have to check the root position at each level, and it should be greater in size at each level, and then only we can make the tree. So this is the procedure for making the tree. Once you make the tree, now you have to apply this. Now if you talk about this the elements here, right, everywhere wherever these elements are greater or the smaller in size, what we'll do, we'll always swap the numbers. For example here at this level, if you're making that Max-heap method, right, so 16 here it is greater, right, than this root node. What we'll do, we'll swap this element and we'll make at this next level. Same thing if you're talking about this 2, right, 2 is greater than this 1. Again we have to swap this number. Now here this 3 is smaller than this root child node. Okay, now this 4 here, this 1 is smaller than this 14, and here 4, right, and 16 and 10 both are greater than this 4. So that means whenever we make the tree, always at each level we have to check the number, whatever we are adding, the elements which is added to the tree, that should be greater in size at the root level, and the child node should be smaller in size than the root node. Then only we can make the tree, and after making the tree we have to perform the sorting. Now already we have made the tree. Now the next part is how you are making this build max. Okay, for example, when you take the element, so this will have a element here, right? So the 16, 4, 10, 14, 7, right? So if you take this number, first number is here 16, right? The second element will be the left child of the 16, and the third element will be the right child of this 16 only. Now here we're talking about this Max-heap method, right? And in case of Max-heap method, the numbers would be smaller in size, right? Now, next element we are taking in the left side. Yes, the next element we are also taking now. But if you talk about this, the next element, now this 14 is greater than the child root node. What we'll do, we'll swap this 14 at this particular way. Why? Because we are applying this Max-heap method, and that number should always be greater in size. That this is the method of this Max-heap. The next one is we are choosing this next element, that is 7. It is smaller than this root node. Now the next element, now it will be chosen here. Now you can see here that 8 is greater than this root node. Now again we have to swap this number, right? So it will be swapped. Now if you check the entire elements, right, this is the final element where this 16 and this last that is 14 and 10 both are the smaller numbers. At this level that 8 and 7 both are the smaller number. At this level that 10, 9 and 3 both are the smaller number. At this level that 8, that 2 and 4 both are the smaller number. 1 is a smaller number, right? So we'll go to the next. How to perform the sort. So that was the method for making the tree. Now we have to perform the sorting strategy. First of all, build Max-heap from unsorted array, as we have seen that how we are making the tree. Second is find the maximum element, that is E1. And whenever we get the maximum element, we have to swap. So swap AN as well as E1. Wherever you are getting the number, you have to swap the number. Now the max element is at the end of the array, that means at the top. Then discard node n from the heap. Means we have to remove the top of the element. We have to remove the top of the element and we have to keep at the last position number. So discard node n from the heap. That means by decrementing heap size variable. So every time the greatest number will be shifted at the top position and that number will be discarded and it will be shifted at the last place number. This process will be repeated again and again. Second time it will be for the n-1 place. Third time it will be for n-2 place. That will be repeated again and again. Now the root may violate the Max-heap property, but its children are Max-heaps. So what we'll do, we have to repeat this process until the entire heap will become empty. So now see this is strategy, how we are making this element. The number of elements are you can see here that 16, 14, 10, 8, 7, 9, 3, 2, 4 and 1. Now we have to do the sorting as we have seen, right, how we are making this tree. Okay, so every time this you can see this top of the element, right? Now I will go back, I will show you again. We have to remove the top of the element and it will be shifted where at the last position. Now 16 is at the top. 16 is at the top. 16 will be removed and it will be shifted here at this position. This is the last position element. And this place will become empty. So whatever elements, whichever element is greater in size, that will be shifted to the top position. Now you can see this element here. As I said, Here it was 14. 14 was greater. So 14 and 10. Out of 14 and 10, 14 was greater. Is shifted to the top place. And the top element is shifted at the last position number. Now the number will be sorted. 16 will be sorted. In the next step, now this top element will be removed and it will be shifted at this place, at this ninth place element. Now again, out of these two elements, whichever is greater number, now out of 8 and 10, 10 is greater. Now 10 will be shifted at this place, at this position. And now this place will become empty again, that out of 9 and 3, whichever is greater will come up at this place. Now this place will become empty. Now we are shifting 14 at this place, so 1 will be shifted here. Now you can see this example. Yes. Now 14 and 16 both will be sorted. 14 and 16 both will be sorted. What next? Now we'll remove the next top element. So 10 will be removed and this 10 will be shifted at this 8th position. Now again we'll apply the same process. Out of these two elements, whichever is greater will come up, will take this position. And when this 9 will come up, so this place will become empty. Again, out of this child nodes, whichever is greater will come. So 3 will come here and now this place will become empty. So here this 10 will be shifted at this 8th position. Now this 2 will be shifted at this particular position. I can see this example. Yeah. Now after this step, 10, 14 and 16, all the three elements are sorted. Now this process will be repeated again and again. Now 9 will be the next largest number and next last place, or you can see here this is the last place, for second last, third last, fourth last. So that the next place, next last position we have to replace with the top of the element. Now here this 9 will be removed and will be shifted here. And whichever is greater, that will come up here. So now it will come here. I can see the next example. 9 shifted to this place and 8 is coming up. And once 8 will come up, now the 7 will be shifted here. Now at the next element, next step, as you can see here, 8 out of this two elements, 7 and 3, whichever is greater will come. If 7 will come up here, now out of these two elements, whichever is greater will come. So 4 will come here. And now this place will become empty. Since 8 will be shifted here, then 1 will be shifted here. I can see this. Yeah. Now the next element is to be removed, that is 7, and it will be shifted at this 5th place position. And when we are shifting this, any element whichever is greater, so 4 will be shifted here, and see out of 1 and 2, now this place will become empty, 2 will be shifted and 7 will be coming here at this place. I can see. Same thing in the next step, you can see that 4 will be removed and it will be shifted at the 4th position, or you can say at the 4th place element. And whichever is the next element is greater, that will be shifted to the top position. So out of 2 and 3, now 3 will be shifted. So if 4 will be coming here and this 3 will be coming up and now the 1 will be shifted here. Now you can see at this next element. Again in the next step, 3 will be removed and it will be shifted at the 3rd position. And whichever is greater number, that will come. So 2 will come. I can see 3 will be at this position. Out of that, Now this. So you can see the elements here. This is the process of sorting, where we have to remove all the elements. Now first of all we have to make the tree with the Max-heap process, and after that in each and every step we have to remove the top of the element, and after removing the top element we have to shift at the last position, then second last position, third last position, and up to the last one. So you can see if I arrange the elements, now all the elements are in sorted order. Now you can see this algorithm. If you are starting with this, we have to take the array, then we have to make this, that means you can see this build it, then it will start from n to 1, that means it will all for all the numbers. So at a1 ai, that we have to, when we are making the tree, so it will check for all the numbers, and each and every number should be greater when we are making it the tree, and it goes till n up to n is equal to n minus 1, and then we'll heapify. Heapify means that we are making the tree first, and then we have to sort the elements. And how we are making the tree, so that we have to make the heap also. So that means we have to make the tree, we have to sort the algorithm. So this algorithm is divided into two parts. First, if array is given, we have to make the tree, and how to make the tree, there are two steps, there are two methods. One is Max-heap method, one is min-heap method. So in this example I will be using Max-heap method. And what is Max-heap method? Max-heap means we have to arrange the elements where the root element always be greater in size. So this is the process we have to you have to check in each and every step whenever you take the new element. So once the entire tree is built, now we'll start the sorting of the element. And how the sorting will be done, it is again explained. We have to remove the top of the element always from the top of the step. So top element will be removed and it will be shifted at the last position. And in the second step, again the second top element will be removed and it will be shifted at the second last position. Same thing. So every time the top element will be removed and it will be shifted at the last position, second last position, third last position, up to the n minus 1. So this process continues till we are not making the final tree. So you can see this is a final answer, as we are making this all the elements. Right, so we are removing the element. Firstly, we are removing 16 from the top, then 14 from the top, then 10 from the top, 9, 8, 7, 4, 2, 3, 2, and 1. So if we apply the Max-heap method, the sorting will be done in the form of ascending order. So thank you for watching my video. If you like my video, kindly subscribe and also share with the others. Thank you.